Sai Venkat, and today I am presenting my micro oven project which I developed as a part of my embedded system internship. This project focuses on implementing a microwave oven control system using Emertxe programming and simulated using MPLAB XID and PixSimLab with the PIC16F877 microcontroller. Through this presentation, I will explain the purpose of the project, what I learned, the role of C programming, embedded systems, the microcontroller, tools used and simulation results and key outcomes. In this presentation, I will cover project purpose and goals, what I have learned, C programming, what is an embedded system, microcontroller, microwave oven, and the PIC16F877 microcontrollers. The tools are required to complete this project, key learning outcomes, simulation results and demonstration, and finally conclusion. Project overview and goals. The main purpose of the project is to understand and develop a simulated microwave oven using PIC microcontroller. The key goals of this project are to understand embedded system concepts, to gain hands-on experience with microcontrollers, to implement real-time appliance behavior such as time setting, start, pause and stop variations. This project helped me to understand how software controls real-world home appliances. What I have learned in this project is I learned basics of C programming. I used C program to control microwave oven operations like time setting, start, pause, stop, etc. Used MPLAB XIDE to write, compile and debug the program. Used PixSimLab to test the project without hardware. Learned how timer works for countdown operation. Understood how embedded systems are used in home appliances. C programming plays a crucial role in this project. In this micro oven system, C language is used to develop the control logic. It controls the operations such as time setting, start, pause, stop and countdown. Conditional statements, loops and functions manage the program flow. Timer logic is implemented for accurate countdown and operation. This shows why C programming is widely used in embedded system for real-time applications. During this internship, I gained a comprehensive understanding of C programming, which was foundational to the project. I learned to implement code decision-making logic using control flow statements like if else and manage data with arrays. The training on the functions and pointers was crucial for writing modular, efficient and stable code, which is necessary in memory-constrained embedded systems. Furthermore, the introduction to and its object-oriented programming principles was directly applicable as the microcontroller environment is built on and interacts with sophisticated libraries that use classes and objects. This knowledge enabled me to effectively use pre-built libraries and understand structure of modern embedded code. This training helped me to write stable and reliable code, which is essential when working with microcontrollers and real-time systems. What is an embedded system? An embedded system is a dedicated computer system designed to perform specific function within a larger device. It works by using both software and hardware together to control internal operations. The hardware mainly include a microcontroller such as ARM microcontrollers, PIC microcontrollers, etc., memory and input and output devices. While the software is commonly written in C programming language, embedded systems work in real time and respond quickly to inputs. They are reliable, power efficient and cost effective. Embedded systems are widely used in daily life such as microwave ovens, washing machines, automobiles, medical devices and industrial equipment where accurate control and continuous operation are required. Microcontroller. A microcontroller is a small computer on a single integrated chip designed to control specific operations in embedded systems. It contains a processor, memory, and input-output ports within one unit. A microcontroller executes a program written in language like C to control device and perform tasks automatically. It continuously reads inputs, processes data, and generates outputs based on the programming logic. Microcontrollers are designed to be compact, low power, and cost effective. They are widely used in applications such as microwave ovens, washing machines, automobiles, traffic lights, and industrial control systems. Microcontrollers are compact, low, and cost effective, making them ideal for home appliances like microwave ovens. In this project, we developed a micro oven. A micro oven is an electronic kitchen appliance used to heat and cook food quickly. It works by generating microwave energy which heats the food evenly in a short time. A microwave oven uses an embedded system to control its operations such as time setting, start, pause, and stop functions. The embedded controller processes user inputs from buttons and or keypad and controls the cooking process according to the programmed instructions. Microwave ovens are easy to use, energy efficient, and saves the time. They are widely used in homes, restaurants, and food industries for fast and convenient cooking. It uses an embedded system to control time setting, start, pause, and stop operations. In this project, we are going to implement micro mode, grill mode, convection mode, and start mode. These are the four modes we are going to implement. PIC 16F 877A is the microcontrollers which is used in this project. PIC 16F 877 is an 8-bit microcontroller developed by microchip technology and it is widely used in embedded systems. It contains a CPU, program memory, data memory, timers, and input-output ports on a single chip. It supports programming in embedded C and is suitable for real-time applications. The microcontroller has multiple I/O pins that allow it to interface with devices as displays, keypads, and sensors. Due to its low cost, low power consumption, and easy programming, PIC 16 of 877 is commonly used in programming like projects like microwave ovens, home appliances, and industrial control systems. It supports embedded C programming and is suitable for real-time applications. Due to its low cost and ease of use, it is widely used in home appliances and industrial areas. Tools required. To write a code and compile and debug the code, we are using MPLAB X IDE. We can also create projects in this. MPLAB XID is an integrated development environment used to develop embedded applications for PIC microcontrollers. It is mainly used to write, compile, and debug programs written in embedded C language. MPLAB XIDE provides tools for project creation, device configuration, and error checking. It helps programmers to test and improve their code efficiently before programming the microcontroller. MPLAB XIDE supports simulators and debuggers which makes it easy to analyze program behavior. It is widely used in embedded system development because of its user-friendly interface and reliability. The another tool which is used in this project is PixSimLab. PixSimLab is a simulation software that allows testing without hardware. PixSimLab is a simulation software used for testing embedded system projects without using actual hardware. It allows user to simulate PIC microcontrollers along with input and output devices such as switches, LEDs, and displays. PiximLab helps in observing the behavior of the program and verifying its functionality. It is mainly used to find logical and timing errors in embedded C programs. PiximLab is very useful for learning, debugging, and validating embedded applications before implementing them on real hardware. Let me open my browser. This is the project code. This is microven.c file, main.c file, microven header file, clcd.h file, matrix keypad.c, clcd.c, timers.c, isr.c. These are the header files. Each and every component has a header file and .c file. Let me open my last X file. You can see that powering on microwave oven. There are four modes: micro mode, grill mode, convection mode, and start mode. If we press 1, the power is 900 watts. It is showing. We can set the time in terms of minutes and seconds in this mode. If we press hash, it starts cooking. You can see that the time is decreasing. The fan is also rotating. If we pause, press 5, you can see that the fan is stopped and the time is also stopped. If we restart or resume, we simply click on 4. You can see that the fan is rotating and the time is also starts decrementing. If we want to stop it, we can just click on the 6. You can see that the display is back to the menu screen. The second mode is grill mode. To enter grill mode, we have to click on the number 2. In this mode also we have to set the time. You can clearly see that the time is selected. You can see that the fan is rotating and the timer is running. Just like that, 4 is for start, 5 is for pause, 6 is for stop. If we stop that, it, it, it will back to convection mode. For convection mode, we have to press number 3. In this mode, we can set temperature. I am just selecting 120 degrees. We can clear the temperature also. See that the temperature is cleared. After entering the 60 seconds preheat starts occurring. You can see that the preheating screen time remaining is 50 seconds. After that, we have to select the time. Let's wait until the time is comes to check. You can see that the time is already entered. Enter. The fan is rotating. I'm just stopping it. Fourth mode is start mode. When we press start mode, it automatically takes 30 seconds. If we press key 4, it will add 30 seconds. After after time is over, they will the message will the screen will display a message like the time is completed. Enjoy your meal. Let's wait until the time is clear. You can see the time of enjoy your meal. It again comes to micro. You can also reset the time also. If we enter 5 seconds, you can see that when I press start, the time is clearing. This is about the project demo. Simulation results and demonstration. The micro event project was successfully simulated using PiximLab with the program developed in MPLab XAD. The simulation verified correct operation of all functions, including time setting, start, pause, resume, and stop. The countdown timer worked accurately according to the programmed logic, and display updates were observed in real time. User inputs were correctly detected and processed by the system, demonstrating proper control flow and timing behavior. The simulation results confirmed that the Emertxe program performs reliably and meet the expected functionality of a microwave oven control system without using physical hardware. Key, key learning outcomes from this project is gained understanding of embedded systems and their applications, learn to write and implement embedded C programs, understood how to control system operations using software logic, gained hands-on experience with MPLab XIDA for program development, learned to test and debug programming using PiximLab, understood the role of PIC16 of 877A in embedded projects, developed problem solving and debugging skills, gained confidence in developing real-time embedded applications. Finally, the conclusion: this micro-event project successfully demonstrated the practical implementation of embedded systems using embedded C programming. The project provided strong hands-on experience with PIC16 of 877A microcontroller and effective software development using MPLab XIDE. Simulation through PiximLab enabled accurate testing and debugging without the need for physical hardware. Through this project, a clear understanding of real-time control, timer-based operations, and system logic was achieved. Overall, this project strengthened technical skills, problem-solving ability, and confidence in developing embedded systems applications for real-world consumer devices. Thank you for giving me this opportunity.